Something just happened in our solar system that should not be possible, and the evidence is no longer theoretical. At 14 UTC, the European Space Agency released 122 images captured by the JUICE spacecraft, and those images quietly dismantled everything we thought we knew about comets. The object known as 3IATLAS is emitting high-velocity jets from the side facing away from the Sun, not the warm, illuminated hemisphere, the dark, frozen night side. That single fact alone breaks the basic rules of cometary physics. If sunlight is not touching that surface, nothing should be moving. Yet something is pushing back against space itself. In classical thermodynamics, comets are passive objects. They drift. As they approach the sun, solar radiation heats their surface, frozen gases sublimate, and jets naturally erupt from the sunlit side. Radiation pressure then sweeps those gases backward, forming the familiar tail that always points away from the Sun. This process has no intelligence, no intent, and no directional control. It is heat in, gas out. That is the rule. But JUICE has now documented jets emerging from the exact opposite side, where temperatures should be collapsing toward the cosmic background minimum. That surface should be inert. The Janus camera shows something else entirely. These jets are not diffuse clouds. They are narrow, bright, sharply defined columns of material emerging with speed and structure. For matter to be expelled from the dark side, heat must be coming from inside the object itself. That immediately removes solar energy from the equation. Whatever is driving this behavior is internal, regulated, and active. Through a theoretical lens, this suggests propulsion, not outgassing. To push material outward from a frozen hemisphere, energy must be generated within the core and routed through controlled release points. Data modeling shows that these jets are aligned forward, opposing the object's direction of travel. That is not random. In aerospace engineering, expelling mass forward slows an object down. This is braking. At a velocity of nearly 66 kilometers per second, 3IATLAS is shedding speed with precision. This matters because of where it is going. Jupiter's Hill radius marks the region where the planet's gravity overpowers the sun's influence. Objects do not gently arrive there by chance. Natural bodies either slingshot past or crash. They do not decelerate unless something makes them, and rocks do not decide to slow down. Telemetry adds another layer to the anomaly. The MAGIS instrument detected methane concentrations 11 times higher than anything ever measured in a natural comet. Methane is volatile and short-lived. It does not linger unless continuously replenished. That points to storage and controlled release. At the same time, the PEP instrument recorded dense streams of ionized nickel mixed into the jets. Nickel is not common in cometary plumes, but it is common in high-temperature alloys used in engineered systems. The implication is uncomfortable, but unavoidable. The jets may not be gas-escaping ice, they may be exhaust. Ablative propulsion, where internal structures are deliberately eroded to generate thrust, would explain both the metal ions and the heat signature. This would allow a massive object to maneuver without conventional fuel. Then came the pulses. The ultraviolet spectrograph showed the jets flickering rhythmically, not continuously, but in controlled bursts. In information theory, pulsed emissions indicate regulation. These bursts align perfectly with the object's rotation, meaning thrust is applied only when it produces the desired vector change. That requires timing, calculation, and correction. This is not stress cracking, it is navigation. And that brings us to Jupiter. A destination that does not forgive mistakes. Jupiter is not just another planet, it is the dominant gravitational force in the outer solar system. Its mass is so extreme that it acts like a cosmic vacuum cleaner, either slinging objects back into deep space or pulling them into violent destruction. In classical Newtonian mechanics, an interstellar body approaching at this speed should follow a clean, predictable curve. It should whip around the planet once, gain energy, and disappear forever. That is what nature does. That is what equations demand. But 3IATLAS is not following that curve. The forward-facing jets documented in the new imagery show the object actively trimming its trajectory. Instead of surrendering to Jupiter's gravity, it is resisting it, shaving off velocity in carefully timed intervals. This is not survival by chance. This is controlled braking. At nearly 66 kilometers per second, even a small adjustment requires enormous energy, yet the data shows those adjustments happening smoothly, without chaos, and without any sign of chemical propulsion. This matters because slowing down near Jupiter is not optional if the goal is to stay. Jupiter's gravity well is steep. To avoid a slingshot escape or a catastrophic plunge, an incoming object must lose a precise amount of kinetic energy at exactly the right moment. Miss that window by even a fraction, and the encounter is over. Natural objects miss it every time. 3IATLAS is not missing it. The theoretical models now converge on a single conclusion. The object is not aiming for impact, and it is not passing through. It is attempting orbital insertion. If a mass this large successfully enters a stable orbit around Jupiter, it will become something the solar system has never seen before, a captured interstellar body that did not arrive by accident, not a fragment, not debris, a permanent resident. The imaging data reinforces this interpretation. Natural comets produce chaotic comas, diffuse clouds of dust and gas that expand unevenly. What we see here are narrow, sharply defined beams. In plasma physics, such collimation does not occur without control. Matter does not spontaneously organize itself into tight columns. To do that, you need magnetic confinement. You need fields shaping flow, guiding exhaust, and preventing dispersion. That level of control implies a power density far beyond anything expected from a frozen relic of planetary formation. It suggests active systems capable of generating and maintaining strong magnetic fields while operating in deep space. In other words, it suggests engineering. As this realization settled in, the response across the scientific community was immediate and unprecedented. Observatories across Earth and orbit were retasked. Every available sensor was pointed toward the Jovian system. This was no longer a curiosity. It was a countdown. The 16th of March 2026 became the focal point, the moment when theory would either collapse or be rewritten. If the jets fire again near Jupiter's Hill radius, and if the object's velocity drops just enough, then orbital capture becomes unavoidable. That single maneuver would divide human understanding of the cosmos into two eras, before intentional interstellar arrival and after. To understand why this possibility is so destabilizing, we have to return to the most basic principle governing the universe. The second law of thermodynamics: order decays, systems drift toward disorder. Comets are textbook examples of this rule. They are shaped by external heat, not internal purpose. They react, erode, and fade. But the 122 images released so far show the opposite: order increasing, structure replacing randomness, energy emerging from darkness where none should exist. This is not a minor anomaly. It is a systemic contradiction of how inert objects are supposed to behave. Cryogenic physics makes this especially clear. A surface locked in shadow, approaching temperatures near the cosmic background minimum, cannot suddenly eject high-pressure material unless something inside is generating heat. That means an internal energy loop, isolated from sunlight, operating continuously. The forward-facing orientation of the jets confirms their role. They are not vents, they are thrusters. They are not responding to Jupiter's pull. They are pushing back against it. And that behavior leaves only one interpretation standing. Whatever 3IATLAS is, it is not falling toward Jupiter. It is choosing to arrive. That choice becomes even harder to ignore the deeper we examine the propulsion data. The particle environment package detected dense streams of ionized nickel mixed directly into the jets, and that single detail changes the interpretation completely. Nickel is not a volatile ice. It does not sublimate in sunlight, and it does not appear in cometary plumes by accident. In material science, nickel is associated with high-temperature structural alloys, the kind designed to survive extreme thermal stress. To strip nickel atoms from a solid and eject them as plasma requires internal temperatures exceeding 3,000 degrees Celsius. That kind of heat cannot exist inside an icy body unless it is deliberately generated and tightly controlled. This is where the picture sharpens. Maintaining such temperatures inside a 33 billion ton object without catastrophic structural failure would require magnetic confinement, the same basic principle behind experimental fusion reactors. Theoretical modeling now suggests the object is using an internal magnetic field to pinch and shape its exhaust into the narrow, columnated beams seen in the imaging data. This is not random erosion. It is ablative propulsion, a process where small portions of internal material are intentionally sacrificed to generate thrust. The object is not breaking apart. It is burning itself carefully, on purpose. Methane detection strengthens this conclusion. The MAGIS instrument recorded methane concentrations 11 times higher than anything ever observed in a natural comet. Methane is a simple molecule, but in propulsion theory, it is nearly ideal. It stores well at low temperatures, releases large amounts of energy, and burns cleanly when handled correctly. If 3IATLAS carried methane from another star system, it would possess a fuel reserve capable of sustained maneuvering across interstellar distances. The absence of carbon residue explains why distant observatories saw a dark object, while JUICE, operating closer, detected the invisible signatures of active propulsion. The ultraviolet spectrograph revealed another critical clue: the jets are not steady. They pulse. The emissions flicker with a consistent, repeating rhythm. In information theory, repetition with precision indicates regulation. These pulses are not noise. They are timing signals. When correlated with the object's rotation, the pattern becomes unmistakable. Thrust is applied only when it produces the desired change in trajectory. That requires constant calculation, real-time feedback, and adaptive control. This behavior goes far beyond passive physics. A natural body would vent material continuously or unpredictably. It would not wait. It would not time its releases. It would not compensate for its own spin. What we are seeing is guidance, navigation, and control operating under conditions of extreme velocity and gravitational stress. As 3IATLAS approaches Jupiter's Hill radius, the region where the planet's gravity dominates, the object appears to be doing more than slowing down. It is surveying. Jupiter's magnetic field is the largest structure of its kind in the solar system, extending millions of kilometers into space. By emitting ionized plasma in controlled pulses, the object can interact with those magnetic field lines, effectively feeling the structure of the Jovian magnetosphere before committing to capture. This looks less like an approach and more like a handshake. In electromagnetism, coupling two systems requires tuning frequency, phase, and intensity. The pulse jets may be serving a dual purpose, braking the object while simultaneously mapping the magnetic environment it intends to enter. This is reconnaissance performed at relativistic speed. The implications are profound. In orbital mechanics, an interstellar object moving at nearly 66 kilometers per second cannot be captured naturally. It should either collide or escape. To remain, it must lose energy deliberately, at exactly the right time, in exactly the right direction. The data now shows that energy loss is happening, and it is happening under control. The most unsettling detail appears in the latest Janus exposures. The jets rotate in perfect synchronization with the object's spin, maintaining a fixed thrust vector. A spinning body should scatter its exhaust like a sprinkler. This one does not. Valves are opening and closing with microsecond precision, compensating for rotation and inertia. That level of coordination implies onboard computation, far beyond simple automation. This is no longer a question of whether 3IATLAS is unusual. It is a question of whether we are watching a machine make decisions in real time as it prepares to become part of our solar system. At this stage, the only remaining anchor is scale, because scale tells us intent. If a system can guide 33 billion tons of mass with this level of precision, it is not operating under scarcity. It is not scavenging. It is not improvising. Any civilization capable of this kind of control already commands energy on a stellar level. That realization quietly removed one fear while amplifying another. Whatever built this object does not need anything from Earth, which means its presence is not motivated by survival or resource extraction. Instead, attention turns to position. Jupiter is not simply large, it is central. Its gravity shapes the architecture of the solar system, controlling asteroid belts, redirecting comets, and stabilizing planetary orbits. With nearly 100 moons and the most powerful magnetosphere of any planet, it functions as a natural observation platform. From that vantage point, every major body inward of Saturn becomes visible, predictable, and measurable. Parking there is not arbitrary, it is strategic. As 3IATLAS moves deeper into Jupiter's shadow, the telemetry changes again. The methane emissions detected earlier no longer appear diffuse or random. They begin to organize into structured patterns. The ultraviolet spectrograph records bursts of light at specific intervals, frequencies that closely match Jupiter's electromagnetic rhythms when scaled appropriately. In physics, matching frequency is not coincidence, it is coupling. Two systems begin to exchange energy efficiently when their oscillations align. This is the moment where motion becomes interaction. The object is no longer simply braking against gravity, it is synchronizing with the Jovian environment itself. That implies intent beyond orbital mechanics. It suggests preparation for long-term presence. The data also shows a reduction in turbulence within the jets. Early emissions showed minor instability, consistent with initial course correction. As the object approaches capture, those fluctuations disappear. The exhaust becomes smoother, cleaner, and more precise. In control systems theory, this indicates convergence. The system has reached the parameters it was designed for. One of the most telling signals comes from radio science measurements. A subtle but unmistakable shift in carrier frequency indicates a major deceleration event, not explosive, not chaotic, just controlled loss of velocity. No chemical plume accompanies it, no thermal spike. Momentum changes without visible reaction mass. This alone forces a reassessment of propulsion assumptions. If conventional rockets obey Newton's third law by throwing mass backward, this system appears to be interacting directly with fields instead of fuel. Electrodynamic coupling becomes the leading explanation. By expelling ionized material into a magnetic environment, the object can generate force without traditional exhaust. Jupiter's magnetosphere provides the scale, the object provides the conductor. The result is a planetary scale break. This is not speculative physics. The Lorentz force is well understood. What is unprecedented is its application at this magnitude. Linking a moving object to a planetary magnetic field to bleed off kinetic energy is not something nature does accidentally. It requires planning, calibration, and knowledge of the target environment long before arrival. The methane data adds another layer. As the object stabilizes, methane emissions do not decrease, they reorganize. The ultraviolet flashes align into repeating sequences that resemble synchronization protocols rather than propulsion cycles. In information theory, this is the difference between noise and handshake. One announces presence, the other establishes compatibility. What emerges is a pattern that no longer fits the narrative of a passing anomaly. 3IATLAS is transitioning from traveler to resident, from trajectory correction to station keeping, from motion to placement. And placement is everything. A body that enters orbit around Jupiter under its own control becomes a permanent feature of the solar system. It is no longer governed by chance encounters or chaotic drift. It occupies a chosen slot, one that allows continuous monitoring of planetary activity, electromagnetic emissions, and orbital traffic. This is not arrival in the cinematic sense. There are no flashes, no collisions, no grand gestures. It is quieter than that, more deliberate, more unsettling, because when something arrives this carefully, it is not here to be seen. It is here to stay. The confirmation arrived without ceremony, which somehow made it more unsettling. At 23:15 UTC, JUIC's radio science experiment detected a clear shift in carrier frequency from 3IATLAS, a signature that only appears when a massive object undergoes rapid, controlled deceleration. The numbers were precise. The change corresponded to a delta V of roughly 2.1 kilometers per second. For an object with a mass measured in tens of billions of tons, that is not a minor adjustment, it is a decisive maneuver. And yet, once again, there was no accompanying evidence of chemical propulsion. No plume, no thermal flare, no debris trail, velocity changed, but the usual physical footprints were missing. In classical orbital mechanics, this should be impossible. An interstellar object entering the Jovian system at nearly 66 kilometers per second carries far too much kinetic energy to be captured naturally. Gravity alone cannot do the job. The equations are unforgiving. Without shedding energy at exactly the right moment, the object must follow a hyperbolic path and escape back into interstellar space. Flyby or collision are the only outcomes nature allows. Staying requires intervention. The data now shows that intervention happened. The forward-facing plasma jets recorded earlier were not incidental emissions or secondary effects. They were braking thrusters, activated with exquisite timing as the object crossed into Jupiter's Hill sphere. By firing against its own direction of travel, 3IATLAS bled off just enough speed for the planet's gravity to take over, but the mechanism appears far more elegant than simple reaction thrust. Measurements from the particle environment instruments suggest the ionized exhaust was interacting directly with the planet's magnetic field. In electromagnetism, a charged particle moving through a magnetic field experiences a force perpendicular to its motion. Scale that interaction up, and you get electrodynamic braking. Instead of pushing against empty space, the object pushed against Jupiter itself, using the planet's immense magnetosphere as a lever. This is not propulsion in the traditional sense. It is field coupling. This interpretation explains several otherwise conflicting observations. It accounts for the absence of conventional exhaust, the presence of ionized heavy metals, and the smoothness of the deceleration curve. The object was not burning fuel to slow down. It was anchoring itself to a planetary scale magnetic structure and letting physics do the rest. Methane readings reinforced this picture. As the maneuver progressed, methane concentrations did not dissipate as they would in a natural plume. Instead, they became increasingly organized. The ultraviolet spectrograph detected structured bursts of emission that aligned with known Jovian electromagnetic frequencies. This was not random leakage, it was modulation. In information theory, modulation marks the transition from action to communication. At this point, the object was no longer simply interacting with gravity, it was synchronizing with the Jovian environment. Its internal systems adjusted output to match external conditions, reducing turbulence and stabilizing motion. Control theory describes this as a closed-loop system reaching steady state. Inputs decrease because the desired configuration has been achieved. From an orbital standpoint, the implications are historic. 3I.ATLAS is no longer on an escape trajectory. It is no longer inbound on a collision course. It is settling into a stable orbital configuration, one that does not arise from chance encounters. This is capture by design. Once that realization settled in, the narrative shifted again. The question was no longer whether the object would stay. The data strongly suggests it will. The question became why this location was chosen. Jupiter is not just massive, it is influential. From its vantage point, activity across the entire inner solar system can be observed with minimal obstruction. Gravitational perturbations, electromagnetic emissions, even artificial radio signals funnel outward through this region. A permanent presence here is not symbolic, it is practical. By the end of the deceleration sequence, all signs of active thrust diminished. Not because systems failed, but because they were no longer needed. The object had transitioned from maneuvering to maintaining position, from travel to residence, and with that transition, a line was crossed. Because an interstellar object that can arrive, slow down, and stay is no longer just passing through our neighborhood. It has chosen to be part of it. What happens next unfolds at the most delicate crossroads our solar system can offer. With the deceleration complete and the chaotic variables stripped away, the object known as 3IATLAS has entered a regime where only intention can explain its behavior. Telemetry from the final JUICE passes confirms that its trajectory has transitioned into a long-term, dynamically stable orbit within Jupiter's domain. Not a looping flyby, not a decaying spiral, a sustained configuration that mathematics does not allow to occur by accident. In three-body dynamics, this outcome is vanishingly rare. An interstellar object interacting with the Sun and Jupiter simultaneously exists in a gravitational knife fight. Tiny errors grow rapidly. Orbits destabilize. Escape is the norm. Stability requires constant correction, active damping, and real-time feedback. Nature does not perform these adjustments. Systems do. The last burst of data before the object moved fully into Jovian shadow provides the clearest clue yet. The ultraviolet spectrograph detected a sequence of narrowband emissions locked to a repeating interval. These were not energetic enough to be propulsion. They were not random enough to be noise. They were timed, structured, predictable. In signal analysis, this pattern marks synchronization. The object was not fighting Jupiter's environment anymore, it was matching it. Jupiter possesses the most powerful magnetic field of any planet in the solar system, extending millions of kilometers into space. That field rotates with the planet, generating a vast electromagnetic engine. As 3IATLAS aligned its emissions with this rotating field, the interaction between the two systems smoothed orbital irregularities. The result was passive stability without continuous thrust. The object effectively plugged itself into the planet's magnetospheric rhythm. This is not science fiction. The physics is well understood. What is unprecedented is the scale and precision. Using a planetary magnetic field as part of an orbital control system implies an engineering